Yes, sir.
So
Otherwise, they can unmute their mics and they can ask their questions, sir.
yes, they can do that. Okay. So I'm just presenting my screen. Okay. Just let me know if you are able to see my screen.
Sir, your voice was not audible, sir, clearly.
My voice isn't audible.
Yes,
Is it
sir.
now? Is it better or worse or
Better, sir. Better, sir.
we live in this technology world, so we need to get used to it. So there's okay. So is my screen visible?
Yes, sir. Visible, sir. Yes, sir.
Fine. So thank you, Kavita, for your wonderful introduction. So thank you very much, and also I'm honored to be one of your source person to share uh, a few insights where we can use this artificial intelligence and deep learning in our lives. So, just let you know that to all the participants, a very good morning and I welcome. And I hope my talk on this deep learning would be beneficial to you. Not only beneficial, but to give you more insights by which you can use it in your daily life. So, before I proceed further, I just want all the participants know that I am not into teaching profession. So please be informed of that. So my talk and everything will be very, very brief. And hope I think our talk today will be beneficial to me and also to each one of us. Right? So before we go into it, so if you look into the present statistics and minute on the internet in 2020, every hour 500 hours of video has been uploaded by users in 1 minute. In 1 minute, 500 hours of video has been uploaded by users. For example, if you want to watch all the videos that are uploaded in YouTube in a minute, probably you need around 2 to 3 months sitting at a time doing nothing, just viewing it. And around 350,000 stories in Instagram. So all the reason why I put forward this slide is to let you know that the amount of information that the people in this world are uploading is enormous. You see, 500 hours of video uploaded in one single minute. It looks very, very strange. And you can see in the Netflix around 400,000 hours. That means 4 lakh hours of video streamed by users in a minute. So you can see that the amount of data that is being inflowing through the internet is very, very enormous. So just want to give you insights of that. So if you are not capable of using the information, our future might not be bright. So over the last recent decades, the main focus is on building intelligent machines that can perform certain tasks like just humans. So I participate in a number of business meetings in my company and outside the company. And one theme that has been shared by all the CEOs is in the coming 1 2 3 years they want to invest more on technology rather than human capital. That means if the technology could perform things in the same way a human does, why don't we invest on machines? Investing on machines, I know people have different views, but when you invest on people rather than machines, the monotony of people get reduced And as a result, people can spend their quality time on some other things which are of interest and which will promote well-being. For example, if you ask if a person is doing the same work continuously for years together, the chances of that person getting monotonous with the same task is very, very high. And the side effect of that is the person well-being is being affected. So thing is, if the same monotonous and repetitive work can be outsourced to machines, then the person can spend quality time on some other things. So if you want, we can talk continuously on the advantages of machine learning. But one of the main advantages is that we can outsource repetitive tasks and the things machines are capable to machines. So other advantage of deep learning is it is a branch of artificial intelligence. As you can see in my previous slide, is the total thing is artificial intelligence, and within artificial intelligence there is a subset where it is called deep learning. So deep learning, the aim of the deep learning, it is a aim moved as machines learn closer to its original goals. And also it is also called deep because it has more than one state of non-linear future transformation. So we can talk about what is non-linear future transformation in the coming minutes that are ahead. And one of the advantages that deep learning has, it can automatically learn future representation at the multiple level of abstraction. Generally, machine learning, whenever you want a machine learning model to learn, you need to tell them, you need to give them the features. For example, if thing is round, it need to assume that it is ice or something like that. So, but the advantage that you have deep learning is there is no need for you to give the features. It can learn automatically. So today agenda we will be covering on the few things like what is artificial intelligence and the fundamental component of artificial intelligence is neuron. When you talk of neuron, there might be biological neuron and artificial neuron, and we will understand the difference between a biological neuron and artificial neuron. And then we can briefly talk about the artificial neuron. What is an artificial neuron? And what are the components of an artificial neuron? And then we talk about the layers. When I say layers, what is an hidden layer and what is outer layer and what is the output layer. And then we can talk about the activation functions. As you know, activation functions are the crucial for any neural network to perform well. And then we have this gradient descent. Then finally, we will talk about a single layer perceptron and a multi-layer perceptron. And then we will talk about the convolutional neural network. And then after which if we have time, I think we can go very little about this RNN, recursive neural network, recurrent neural network, and LSTMs. And this is what our agenda looks like. I hope my talk is audible and my voice is clear. Can I get some feedback, please?
Yes, sir, no problem.
Okay, good. So I want to ensure that I'm not talking to people. I want to ensure that I'm talking to people because since it's an just let me know. Just please free to interact. Please free to text or chat if my voice is not clear or if there's any technology related problems, right? Okay. So the applications of artificial intelligence, self-driving cars, Tesla, I think I don't know how many people are following the stock market. The share value of Tesla is increasing tremendously. That means people are willing to invest. People believe that the self-driving cars would be the future. So for the self-driving cars, that the brain behind the self-driving cars is artificial neural network, ANNs, neural nets. And then you have this language translation. A person who is in a different country in a different language, rather than having a person who can translate, your mobile can help you to translate. The same with detecting credit card frauds. For example, the credit card companies, whenever they notice any outlier, for example, you have been using your credit card for a few thousands every month, 10,000 or 5,000, 2,000 for your regular use. If at all, if any credit card companies find a transaction that is all of a sudden they find a transaction of 1 lakh, then the system will automatically flag saying that this is an outlier and immediately make a call to that respective person, and then it is going to confirm, it is going to ask you a confirmation saying that you have performed a transaction of 1 lakh on particular date. Do you want us to approve it? And if the person who is taking the call says yes, then only the transaction is approved. If the person says no, then the transaction will be declined. So this is all automated. Previously, credit card companies, the people used to call. Nowadays, it is all automated. Now it is the robots or it is the artificial intelligence systems that are making calls, thereby protecting the interest of the consumer. And also you have the recommended engines. I think I cannot dwell much into it. For example, this Netflix, it recommends based upon your profile. And then you have this facial recognition. So with this COVID, people are very, very scared to keep the thumb on the biometric devices. So all the companies will be moving to this facial recognition, where instead of keeping their thumb, the system will automatically recognize the face, and then it will give access to this person. So the applications of AI is listless. We can go on talking. Other advantage that we have with this artificial intelligence is the health risk assessment, which is going to be very, very useful for the insurance company. So with this COVID, people are flogging to buy health insurance packages. So if a person, if he has already a disease, or if he has some chances that he's going to get affected with an particular disease, the artificial intelligence or predictive analytics can take care of this and will alert the insurance companies, saying that the chances of that person getting some chronic disease is quite high, so the premium need to be adjusted accordingly. So these are all the advantages that we have when we are using artificial intelligence. So that is the few introduction about artificial intelligence, and then we will go into this thing. So biological neuron, it is the most fundamental thing, that fundamental component, fundamental block of a neural network. It is one of the complex things in nature. So if, for example, our human brain, scientists say that it has around 86 billion neurons in our brain. And all this neural brain, all this 86 billion neural networks, they operate in layers. And when all these 86 billion neurons work together, we are able to make complex decisions, whether to go or not on all these things. So our brain is the motivating thing by which these artificial neural networks are formed. So the biological neuron, it consists of three parts. One is the dendrite, and the dendrite are they receive signals from other neurons. And when the signals are received from other neurons through the dendrites, it goes, all the dendrites are connected to an what we call the cell body, which is called the nucleus. And this nucleus, they take the inputs from all the dendrites, do some calculation, and give a final output. And that final output is transferred to the other to the adjacent neurons through axon. And the signal that is transmitted through the axon, the whether it can be transmitted or it need to be suppressed depends upon the threshold. So if the strength of the signal is very, very high, the signal from the nucleus is transmitted to the other neurons. On the contrary, if the signal is weak, then that signal will not be transmitted to the other neurons. And the synapse is the connection between the axon and other dendrites. So this is the biological neuron is used in replicating the artificial neuron. So, and this is what it is called an artificial neurons. As I told you before, the artificial neuron which we used in the artificial neural nets is a replica of biological neuron. This is also called perceptron. So if any person says perceptron or anything like that, so don't get confused. It is another way of saying an artificial neuron. As I told you before, the artificial neuron, it is the basic unit of a neural network. So when you talk of computer logic or other things, it can be considered as a simple logic gate with binary outputs. So inputs in biological neuron, it is called dendrites, and the weights, it is called the synapses. And each neural artificial neuron has the following functions. It takes input from the input layer. That means it takes the inputs from these neurons, takes the input from the inputs, and then it calculates the weighted sum. When you say weighted sum, don't get confused. It is just a function by which it takes a number of inputs and spits out a single variable. That is what we called as an weighted sum. It is also called an activated function. And then this, when the sum is aggregated, it goes through an activated function. So the function of the activation function is depending upon the strength of the weighted sum. It will decide whether the signal should be transmitted to the next layer or not. For example, if we have a threshold where we say that any signal that is less than 0.5 should be stopped, and any signal that is above 0.5 should be passed. That is the rule of an activation function. So what the activation function is, as soon as it receives the weighted sum from the input function, the activation function will decide whether it should send that output to the next layer or not. In our case, what we have decided, what we have told the activation function is any signal that is above 0.5 should be transmitted. Anything less than 0.5 should be blocked. So based upon that, it will perform. So this is a schematic diagram of an perceptron. Very, very simple. It takes an inputs, and then it got the weights, and then it calculates the weighted sum. Once it calculates the weighted sum, it goes through an activation function, and the activation function decides whether the function should be activated or not. That is how an artificial neural network works. And then this is the comparison between a biological neuron and an artificial neuron. So in our brain, we have around 86 billion neurons and 1,000 trillion connections. That means it is very, very huge. For people who are who have some ambiguity what a billion is, a billion is around is 100 millions, 1,000 millions. 1 billion makes 1,000 millions, and 1 million is around is not around is 10 lakhs. So that means you can understand how big is our brain. 86 billion neurons, and those neurons, they have close to 1,000 trillion connections. That means 1 neuron will be connected to other neurons, and those connections are close to around 1,000 trillions. You can understand how huge is our brain. And when it comes to the artificial neuron, our artificial neuron in a typical neural net is around 10 to 1 lakh neurons. And those neurons may or may not be connected to the next layers. So consider to our human brain, our artificial neuron, our artificial neural network is very, very small. And the other advantage that the biological neuron have, it will compute one by one. That means it is asynchronous. For another neuron to work, it needs to pass. Once that means it for the other, it is sequential. In other words, it is sequential. For example, if there's a task called A, so the task B will resume only after the A task is completed. While as in artificial neurons, they work asynchronously. They work in parallel, and the speed is around the activation functions in our brain. They are close to around 200 times a second on an average. In a second, it can process 200 times 200 operations in 1 second. While as in artificial neuron, it all depends on your CPU or a GPU or a cloud. It all depends upon machine. It is machine dependent. A machine with higher speed, your speed will be much faster, and probably you might have noticed. Other advantage that we have is it is fault tolerant. For example, if a particular neuron has been damaged because of some issues by an accident or something like that, or if a person is sick, the amount of energy that goes to the brain is quite less. So the chances are the neurons sometimes can be damaged. But the good thing about this biological neuron is it can repair itself. While as artificial neuron, it cannot repair itself. If it is damaged, that's it. You need to get it replaced. And the main advantage, the pivotal point is that our biological neuron, they just consume around 20 watt power. 20% of ordinary energy goes to the brain. It's extremely, extremely energy efficient. Whereas the machines, the GPU and all these things, they need more power, more processing, and more heat is generated. Probably you noticed that whenever you are performing any artificial neural, any modeling using ANN, you will notice that your laptop or its CPU or a GPU, it generates more heat. While as our human brain, even though it is much more efficient, it doesn't heat up. That is the advantage we have when using a biological neuron. So then we have this mathematical representation of perceptron. As I told you in the previous slide, this input function, what does it mean? So what it means is it takes the weights and it's and get multiplied and it adds up all these things. It takes the weights and the features. W1 are the weights and X1 are the features, and it got multiplied, and then you add a bias, and then you get Wx plus B. And the activation function, which is also called a stepping function, will activate, it will spit out an input of 1 if it is greater than 0. And if it is less than 0, it will be giving us 0. So other way of representation of this perceptron is W transpose T into X, where W is a vector of weights and X is a vector of features. For you to explain, I can show you a small diagram where you can understand what this transpose and all these things mean. Are you able to see my screen, please? I changed my screen. Just a minute, please. Madam, can you see the screen? Hello?
No, sir.
You are, you are unable to see my screen.
The screen is visible, but the PPT which you have projected is not visible.
No, I think, can you see my perceptron screen? No, not yet?
No.
Just give me a minute. Now, can you see it? Excel screen, Microsoft Excel.
Yes, sir, we can see.
Okay. So I want to understand, give you an explanation what the weights are and what this thing are. So if you see here, the X, capital X, it is the input features, X0, X1, X2. So this is a vector of size 4. And the weights are WB, W1, W2, W3, and W3. So these are two vectors, X and W. So our the activation function is nothing but X transpose into W. So if you see X, it is an matrix of 1 by 4, right? It has got a rows of 1 and 4. So if you see this vector this X, it has got 4 rows and 1 column. So it is 4 by 1. And other thing, weight, it is also 4 by 1. So if we are probably studied in our education. So if you want to multiply two vectors, you cannot multiply a 4 by 1 and then 4 by 1 vector. If you want to multiply, the thumb rule is the columns in the first vector and the rows in the second vector needs to be same. For example, in order to make sure that the number of the columns and the first vector and the rows in the second vector are the same, what we do is we transpose the first vector in such a way, when you do the transpose, what happens is the rows and the columns gets interchanged. So when you do that, you can see in the when you apply the transpose to X, the vector will be changing to the same directions. It gets swapped to one column and 4 rows. So when you do that, your matrix multiplication becomes easy. So when you're doing that, you can see it X transpose into this thing is, there's a function in Excel where you're taking the matrix of where you're taking the transpose of this first matrix. That's why it is saying transpose of this matrix multiply by the second matrix. The reason why I'm using transpose is to ensure that the matrix multiplication is possible. If you are not using transpose to one of the vector, the problem is you cannot do a matrix multiplication. So that is the reason, in order to ensure that we get a scalar, one of the matrix is transpose to ensure that we can perform a matrix operation for the two vectors. So when you do the transpose to the first vector, the size changes to 1, 4, and the second thing is already 4, 1. So you can see the number of rows in the first vector and the number of rows in the second vector are the same. So the output will be n vector 1, 1. So that means it is a scalar unit. So 1 into 1 plus 2 into 0.5, 3 into 0.99, and 4 into 7. As a result, the product that the matrix operation between X transpose and weight transpose is always a scalar. So that's what this is how you are getting this thing. So I'm again going to my second screen. So just let me know when you are able to see my presentation. Yeah. Just let me know if you are able to see so that we can continue.
Yes, sir, it is visible.
Okay, fine. So I hope you got to understand why we are using transpose when you are calculating that scalar. And also remember that when you are doing it, the output is always a scalar. When I say scalar, it represents a number, not a vector. The opposite of thing is. Okay, so as I told you before, artificial neuron, it takes it consists of one input values and one input layer, and then you have the bias.
ఇన్స్టాల్ చేయాల్సి వస్తుందండి టీమ్ మైక్రోసాఫ్ట్ రోజు ఒక క్లాస్ కదా, అదే రోజుకి 3 సెషన్లు కదా,
Mathematics.
రోజుకోసారి ఇన్స్టాల్ చేసుకుని పెట్టుకుంటే సరిపోతుంది.
Mute it, please. Okay.
Marvel.
So it consists of input values, and also it has one input layer, weights and bias, activation function, and output layer. So then we will talk about weights. So what are weights? So weights as well as bias, they are both learnable parameters. When I say learnable parameters, what I mean is during the modeling of our model, the weights and bias are changed with every iteration, and the weights and bias, they are both changed till we get an error which is the bare minimum. So what I mean is the weights and bias, they are not constant. They keep on changing till the loss computed by the model is the minimum. And so neural network, when we start the process, when we start modeling the process, it takes a random weights. For example, you can initialize the model using some random numbers. Generally, you can use 1, 2, 3, whatever, some random numbers. Then as the model learns, keeps on learning, it keeps on changing the weights and bias till the model is giving an error that is the bare minimum. So that's what it means. As the training continues, both parameters, when I say both parameters, the weights and the bias, they are adjusted towards the desired value and the corrected input. So the two parameters, the weights and the bias, they differ in the extent of their influence about their input data. So it all depends upon the input data. And the weights is also called the strength of the connection. The weights can be positive, that means it has a positive influence on the output, and also the weights can be negative, that means the weights has a negative influence on the final output, and also the weights can be zero. When I say the weights can be zero, that means that particular neuron has no influence on the result. So it can be positive, or it can be negative, or it can be zero. So the weight, the higher the weight, that particular neuron has a greater influence on the final output. For example, if the weight is 1, that means it has a greater influence. On the contrary, if the weight is 0, you can say that particular neuron has no influence on the final output. And the lower weight will have no change in the input, and alternatively a larger weight will have more significantly, will impact the output significantly. So the weights and bias, they are both learnable parameters. So the bottom line of any artificial neural network is, if you are able to change the weights and the bias, then then your model is perfect. So the artificial neural training is the process by which the weights and the bias are set in such a way that the error is the minimum. So that's what it says about weights. Then we have this bias. So what does bias means? Generally, when you talk of bias in our own language, bias tends to have a negative meaning. For example, in our daily life, we see a number of biasness. For example, you can say that a particular person is more biased to something. For example, a person likes English movies, and other person likes Telugu movies. We can say that the person who likes English movies is biased towards English movies. And the other person who likes Telugu movies, we can say that the person is biased towards the other movies. So the bias has a lot of negative sense. So we live in a world where unfortunately where there is a lot of biasness. So biasness is something negative in our day-to-day life. But in real life, but in our machine learning, bias does not have a negative meaning. In fact, it is very, very useful in order to have our model predict in a non-biased way. That means if you have bias in your model will be more, it will be more efficient. And if you do not have bias in your model, your model might not be efficient. For example, what do bias data do in our model? For example, there are two cases which I have listed you. So in all of you know this company called Amazon, right? Amazon is the #1 e-learning company in this world and e-tailing company in this world, and they're the market leaders. So when Amazon was hiring people, the team of engineers at the Amazon, they developed a tool, a recruiting tool. The job of the recruitment tool is to filter some resumes and select only some resumes which are the most promising ones. And it did a great job. It was able to get candidates. But after a few months of using it, the system, the recruitment tool that Amazon was using, it was selecting only the male candidates for engineers. And thereby, even though female candidates has the potential, thus the recruitment tool developed by Amazon, it was not throwing out the female candidates. That means what I mean to say is that model was designed in such a way that the model was trained in such a way that the system thought that the male candidates might be better engineers. So the story is different. Later they found it and there's a dump using that recruitment tool. So the reason why I'm telling you is, if you are giving a biased data to an model, it is going to throw out a biased input. The case with this Amazon recruitment tool. Another thing that we can quote is the chatbot developed by Microsoft. The model name is TAY, T-A-Y. So the intention of the model, it was to carry conversations by analyzing the tweets. So that model was able to learn the content posted by the user. And what happened was, if the content posted by the users, if it is offensive or if it is aggressive or consists of some words that are not to be used, the model learned all those words and it became biased. That means it was giving rude answers to the people who are using that model, the TAY model, that chatbot called TAY. As a result, it was getting more, the chatbot was responding in a way that it has become offensive, humiliating, and people were not given respect by this model. So Microsoft later found out that there are some irresponsible users who used abusive posts, who inputted the model with abusive posts, and as a result the model became very, very abusive. So the two examples that I've quoted, the recruitment tools used by Amazon and the chatbot that are used by Microsoft, they both became biased. The reason it became biased was it was given a training data which was biased and which was offensive. So as a result, the model became biased. So, but in machine learning, bias is very, very important. So I will show you an sheet by which you can understand what I meant. Madam, are you able to see my other screen, please? Someone tell if you are able to see my screen or not.
Yes, sir, it is visible.
My Excel screen is visible, right?
No, Excel screen, no.
Oh, actually, it's getting pain. Okay. Now I think you should be able to see it. Okay, I think you should be able to see it.
Yes,
Okay.
yes, sir.
Okay, I am with the bias, right? Bias. Okay. So this is an nothing but a linear equation where x is an input variable and this thing is the output variable. So you all know that the most popular linear equation y is equal to mx plus c, right? Y, that means the output is equal to mx plus c, where m is nothing but the slope, which we also call the coefficient, and c is the bias. Y is equal to mx plus c. For people who are interested how you got 13 is I used a slope of 3 and the bias of 10. So as a result, what happens is, so if you see y equal to mx plus c means 10 into 1 plus 10, 13. The same with this thing. So what I did was, if I could plot this number, this graph, so this is y equal to mx plus 10. So this is the line which is passing, right? So since my bias is 10, you can see that this line is intersecting and the other second line is this thing. So the slope is 20. When the slope is 20, what it is intersecting the y-axis at 20. The same line, same slope. I given the bias of 40. You can see 30. You can see that the line is passing through and it is intersecting the y-axis at 30, right? On the other way, if you see this line, it is going downwards. The reason it's going downwards is because the slope is minus 30. So if you are giving bias in your model, you are giving more flexibility to the model. It can go anywhere in the space. If you want to have a model at 60, what you need to do is you need to give the bias of 60, then it will go. So for example, I will show it. I give you 60. You can see the line has moved to 60, right? So just by changing the bias, you can make the line in such a way that it can pass anywhere through that space. For example, keep the bias. What you will notice, so what you noticed, if the bias is 0, you are not giving flexibility to the model to search the entire space of the universe. So that means if your model doesn't have bias, your model becomes very, very rigid. It is not at all flexible. But the same model, same slope with the same coefficients, if you are giving slope, see how it is changing. You see the difference, right? So the advantage that we have when we use slope, when we use bias in our model is you are giving a lot of flexibility to the model. Same model, same coefficients, but if you are not using bias, what you are doing is you are restricting your model. Thereby, when you are restricting your model, that means your model cannot handle data that is beyond its scope. For example, if you have an data that is here in the at 4060, or you can say that minus 340, and if you are not giving bias, how can you think your model will perform? As a result, your error, when you're using a model that doesn't have a bias, the error will be more. So in the advantage of bias in machine learning is bias gives lot of flexibility to your model. If you're not using bias in your model, then your model is rigid and it may not be used for diverse set of data. You're restricting yourself. That's what the bias means. And I hope I am clear on the bias thing. So coming back to the next thing. Why it is it? So I need it. Okay. So the when you do not have bias in your model overfits and your model cannot learn new things from your data. So that's what I showed you. So this is a classical example where you're not using bias. Your bias is 0. When the bias is 0, you can see that all the regression lines are passing through the horizon. So same data, when you are using bias, you can see that it can move anywhere from the origin. It can move up or bottom depending upon your bias. So that's what bias means. Then we can go to the activation functions. So they are basically many activation functions, but they are primarily three types of basic functions, activation functions. One, we have this binary step function. Then we have this linear activation function. Then we have the other activation functions can be grouped as non-linear activation functions. So I will again share my screen. It is getting a big problem for me to toggle between the screens.
Hello, sir.
Yeah.
Sir, some background noise is there, sir.
You are getting background noise?
Yes,
Still,
sir.
just give me a minute then.
Okay.
I think I will switch off the fan or AC.
Okay.
Is it better?
Yes, sir. It's good, sir. Now.
Very good.
Thank you, sir.
So is my voice clear?
Sir.
Okay.
Yes, sir.
Am I clear till now? Are you able to get any meaning from my talk as of now? It's been 1 hour since we spoke.
No, sir. No problem, sir. You can continue the session, sir.
Okay. So are you able to understand my language or my accent?
Yes,
And
yes, sir.
very good. What's your name?
Sir, Venkateswar Rao, sir.
Venkateswar.
From Goodlavalli Engineering College, IT department.
Nice to meet you, sir. Hopefully we can meet you in person. Okay, so this is what a very high level about this activation functions. So you're able to see my screen, right? Excel screen, right? Okay. So what I'm talking is about this step function. So this are some random variables. I just written in code where I asked the Excel to give me a random values between 100 to minus 100. And then I took a sample of around 20 values. And the step function, what the step function does is, if the value is greater than 0, it is going to give me an output of 1. And if the output is anything less than 0, it is going to give me an output of 0. Since the value is negative value and negative values are always less than 0, it is throwing an output of 0. So take the example of 0.67. Since it is greater than 0, you are getting an output of 1. So what the step function does is, if it is a negative value, it gives an input of 0, and anything greater than 0, it is going to give an output of 1. And if you plot all those things, you are getting a curve of this type. So that's what a step function does. Am I clear? A step function, the basic step function is step function takes a value as an input, and if the input is greater than 0, it throws a value of 1. That means it is a positive response. And if the value is 0, if the value is less than 0, it gives an output of 0. In other words, you can consider the step function as a binary type of functions. When I say binary function, it is the output is always either 1 or either 0. So that's what step function means. So 0 if it is greater than 0, less than 0, and 1 if it is greater than or equal to 0. So then we have the sigmoid function. Sigmoid function, the other word for sigmoid is called the logistic function. If you see the logistic function, the formula for the logical function or sigmoid function it is equal to 1 by 1 plus e power minus x. So the same value, what I did was I incorporated in a spreadsheet. The function is, it is equal to 1 divided by, the denominator will be the negative exponential of this number and adding a number of 1. So 1 by 1 plus 1 exponential of negative number. So if you do the same thing for all this number, for example, the output, the input is minus 0.17. So 1 adding to the negative exponential of this number and getting a number of 0.46. So if you plot this, the number x and this number, this thing, you are getting getting some number. And if you observe this thing, all these numbers are between 0 and 1. So if you plot these values, you can see the value is between 0 and 1. Any big number you take, any big number, you take as an input, and the output when you give to the sigmoid function, it will always throw out a number between 0 and 1. For example, in the last case, let us give an 10,000 number. See, it is always 1. Even you give 10, another, you add 2 more zeros, it is still 1. At the same time, if you give a negative number, it will throw a number of 0. Any number, it will throw a number of between 0 to 1. So the advantage of sigmoid function is it is used in logistic regression. So it is sigmoid function, it is primarily used in logistic regression, where the model is for classification problems. If you have a data set and if you want to classify them into two groups, if you want to classify them into two groups, this sigmoid function will be used. So the advantage of sigmoid function is you give an input, and when the input is passed through an sigmoid function, it always throws a numbers that are between 0 and 1. So that's what sigmoid function means. Then we have another function called ReLU. ReLU is extremely used in the artificial neural networks, mainly used in deep learning. So ReLU stands for rectified linear unit. So the problem for this this thing is, for this ReLU is, it will if you give a negative number, it will throw an output of 0. And if you give an input of any positive number, it retains the same number. For example, here in this case is ReLU. So I gave a number of minus 18. When I gave a number minus 18, what ReLU did was, it always gives me 0, irrespective of any number. What it does, it checks this sign. If it is a negative number, don't do any thinking, just throw out 0, spit out 0. And if you give any positive number, what ReLU does is, it gives the same number. You can see, you gave a number of 1 and it threw number of 1. If you give 7.5, any number, it throws a same number. So the ReLU, the function of ReLU is, you take the number, if the number is less than 0, it spits out 0. And if the number is a positive number, it throws out the same number. So the graph will be like an open book. So the number that are on the y-axis on the 0, they are negative numbers, while as this on the positive side, they are all the same positive numbers. The formula for the ReLU is it is the max between 0 and that same number. Anything less than 0, it throws 0, and anything greater than 0, it throws the same number. And ReLU is used for those type of functions. And then we have other function called tanh. The tanh is similar to sigmoid function, only with the exception that the output using tanh function is between -1 to 1. And if you plot it, you can see it is between -1 to 1. So if you throw any number to a tanh function, it will squeeze the number between -1 to 1. That is the advantage that you have when you're using tanh function. Then we have another function called leaky RLU. So leaky RLU is probably the same as RLU, but what it does is it is going to add 0.1 to that number. In case you have a negative number, rather than throwing 0, it is going to multiply the number by 10. You can see 0.1 means 1 by 10. So it is dividing the number by 10 and giving the same output. So you can see the difference between this thing. So it is not 0 for negative numbers, but it is giving a number which is less to some extent. So that's what leaky RLU means. So what we discussed is we discussed about step function. We discussed about sigmoid, we discussed about ReLU, we discussed about tanh, and also we discussed about leaky RLU. So the binary step function is a binary function, and linear functions, it is nothing but our which varies linearly, that nothing but y is equal to mx. And then we have a non-linear function, that means sigmoid, tanh, ReLU, softmax. We haven't discussed softmax, which we can discuss at the later stage. And then we also have called leaky RLU. So it's just a snapshot of what we have discussed. The activation function, step function, the output is between 0 or 1, nothing in between. Sigmoid, the output is always 0 and 1. It is used for sigmoid function, logistic regression. And then we have this ReLU, where the output is 0. Now the input is anything less, if the input is a negative number, and the output is the same if the number is a positive number. And the same with tanh functions. The tanh is similar to logistic regression. It's the same as sigmoid function, only with the case that the output is between -1 to 1. And then we have this leaky RLU. The leaky RLU is the same as RLU, only with the exception that when you give a negative number as an input to a leaky RLU, it does not input 0, but it inputs a far lesser number. That's what it is called as activation functions. So till now we have covered about the weights, the importance of weights, and then also we discussed a few things about this bias, why bias is useful, and if you are not using bias in our model, you are restricting your model. And then we talked about a few activation functions. Then next we will be talking about these loss functions. So what are loss functions? So loss functions, it is typically used. Okay, I will put this way. The essence of any machine learning model is to minimize the loss. When I say loss, the difference between the predicted value and the actual value should be the minimum. So in order to know whether your model is predicting correctly. In order to know what is the difference between the actual value and the predicted value, what you do is you use something called loss functions in order to do that. So loss functions can be primarily classified into three major groups. This is very the basic stuff that I'm telling you, that there might be many loss functions, but these are the basic loss functions which every person should be aware of it. So they can be classified into three things: regression loss functions, binary classification loss functions, and the multi-class loss functions. So when it comes to the regression loss functions, it is there are three regression loss functions. One is called the mean squared error loss, and the mean squared logarithmic loss, and the absolute loss function. So I will okay. So here, for your convenience, I've taken a very small data set where the age is an independent variable and X is an dependent variable. So you give an age of a person and your model will predict the income of the person. So I have a data set from the historical data. I have taken that a person of age 42 will be earning 11 lakhs and a person of age 34 will be earning 58 lakhs, and purely random numbers. This data set does not have any relevance. This is purely an imaginary data set for our understanding. And based upon these two variables, one input variable and one output variable, I have designed and that equation of the model is this thing. Y, the hypothesis, the function is y is equal to, the output value is 0.3398 times x plus 39.487. Here, for the people who did not follow my previous slide, 0.339 is the slope, also called the coefficient. Also in our machine language, it is called feature, for one feature. And then 39.487 is the bias. So y is equal to mx plus c, where m is the slope, also called a feature, also called a coefficient, and 39.487 is our bias. So when I predicted using my model, my model predicted that the income of the person having an age of 48 should be 53.27. How I got 53.27 is I multiplied the age 42 into the slope, which is the coefficient, which is the feature 0.3398, and I added the bias. I got 53.27. Then for the same 34, I did the same. What I did was I took 34 into 0.3398 into plus 39. So these are the predicted values, and these are the label values. Y is the actual values, and column D predicted. These are the values that my model, a simple linear model, has predicted. A person having an age of 42, my model predicted that his age will be 53.27. So what I did is, then I calculated the difference between the predicted and the actual. So the difference is 42.4 and 53.27 minus 11 gives me this thing. And for the second data set, I predicted the error is negative because 50.55 minus 58 throws me this thing. So for all the 20 data sets, for all the 20 records that I have in this data set, what I did was I calculated the error for all these things. For all these things, I calculated the error, right? You see the error. So what the mean absolute error is the mean absolute error, what it does is it converts the negative into positive. For example, the error is 7.45. So what the model does is it ignores the negative side and it takes only the absolute value. So 7.45, I think it is okay. So what it does is, even though it is negative, since I'm taking the absolute value, I got 7.45. Same with 42. So I get the difference. Once I get the difference, I convert them into an absolute value. When I say absolute value, I mean that I am ignoring the sign of it and then taking it, and I'm going to sum all those things. When I sum all those things, what I'm getting the absolute error. So the total error in my case is 571. So when I say 571 is the absolute error. In other words, it is the total error that my model has predicted for one iteration. So when I say mean absolute error is, what I mean is I am taking the average of all these 20 variables. You see in this model, the number of observations are 20, right? The number of observations in this model are 20. So what I does in order to get this absolute mean error is I am summing all those things, and once I sum it, I divide it by the number of samples, and here in my case the number of samples are 20. So my total absolute mean error is 571 divided by 20. 571 divided by 20, and you are getting the absolute mean error as 28.53. That is one thing. That is about absolute mean error. So when anyone talks about absolute mean error, don't get confused. It is very, very simple. What you do is you take the difference between the actual value. That means when I say actual value, means it is the label that the data set has, and you take out the difference between the actual value and the predicted value. Predicted value is the value that your model has predicted. In my case, my model is this thing, y is equal 0.3398 plus 39.487, and column D are the predicted values. I take the difference between these two. Once I take the difference, I take the absolute value. When I say absolute value, I take out the negative sign and convert all those things into positive values. Then you sum it up and then you divide it by the number of samples. That's how you get the absolute mean error. So that the total error is 571, that is the sum, and the absolute mean error is just the average of all those things. And then we have this mean square error. So mean square error is nothing but once you get the error 42.27, what you're doing is you are squaring the error. So you are squaring the error that you are getting it. So 42.27 times 42.47 is 1786. And when you are squaring it, it is what happens is your negative sign gets negated and it turns into positive. So that's how you square the error from all the samples. You sum it. Once you sum it, what you do is you take the average of it, and that it called as mean square error. Got it? So 20.5748 divided by 20. You're understanding 25 divided by 20. You are getting 1027.41. That is your mean square error. 3 errors we have discussed. One thing is the total error, which is the summation of the errors that you get. When I say summation, you're taking the sum of the absolute errors. And then we have this absolute mean error. It is nothing but the average of all the errors that you got. And then you have the mean square error. In the mean square error, what you're doing is you are getting the error, you're squaring the error, and once you square, you are adding all those errors. And then once you take the error, once you get the error, summation of that error, you divide it by the number of samples. As a result, you will be getting the mean square error. Another thing that I did not mention is the root mean square error. RMSC, probably you have heard it. That stands for root mean square error. Root mean square error is nothing but taking the square root of this will give you the root mean square error. So these are all the regression losses: total error, absolute mean square error, and the root mean square error. So probably you will be asking, why should we take the square and then why should we again take the square root? So people say that whenever you are taking the square of the error, the model tends to converge at one point. So if you are not taking the square of the error, the model might not converge. That means your model might not meet. So for anything, your model should converge. So people say that when you are doing the square of that error, the chances are your model is bound to converge at some point of time. So when you're doing machine learning model, there is no need for you to do it. The system will automatically do it. For example, when you are compiling your model, you will just mention that your loss function is mean absolute error. When you say mean absolute error, it is a column G. And for example, if you want to use the mean square error, it is this thing. And if you want to use the root mean square error, you will have the models built up in your model. Then there's no need for you to use it. There's just you just used to keep the right keyword in your compile model, and the system will take care of it. This is all for your own understanding. So am I clear on these regression models, regression losses? So regression models, 3 types. One is the total error, mean absolute error, and then we have this root mean square error. So you can see the formula. What the mean absolute error says that, first of all, it is calculating the difference. Y hat is the predicted value, and Y1 is the label value, and you are taking the difference. When you are getting the difference, you are taking the absolute of that value. And once you get the absolute value, what you're doing is you are summing it up. The sigma says that you are going to sum up all the errors that you got. Once you get the summation, you are going to take the average of it. This is the mathematical way of representing mean absolute error. Other mean square error, the mathematical representation of this mean square error, which in short is called MSE, mean squared error. You are taking the difference. Once you're taking the difference, you are not going to add it. You are going to add only after you square it up. That's what it means. Once you square it up, you are adding all these errors. Once you add it up, you are dividing it by the number of samples. And then, which I did not mention, is the root mean square error. It is the same as the mean square error, but the only difference is once you get that number, you are going to take a square root. Since you have squared it, you are going to do the converts the negation of square, that is nothing but the square root. Once you do the square root, you are going to get the root mean square error. So the problem with this regression losses is they are used only in the regression models. When you say regression models, when you are going to predict a continuous value, these are the times where you can use the regression models. But most of our problems in our daily life, they are not regression problems. They are most of the problems that we handle are classification problems. So and unfortunately, you cannot use the regression losses when you are doing classical problems. So when you want to do a classification problem, the loss function that you need to do is the binary loss functions, and which is called a binary cross entropy loss, which we can discuss after we are done with the break. We can again rejoin once we are finished with the break. Kavita madam? Hello?
Yes, sir. You are audible, sir.
Okay, so we shall join after the break, right?
Yes, sir.
I think the planned break is from 11 to 11:30, right?
Yes, sir. We will
Okay,
again
huh?
join by 11:30, sir.
Yes, so let us correct at 11:30.
Yes, sir. Dear
Right?
participants, yes, sir. Dear participants, please have a break by 11 to 11:30. Thank you. Thank you, sir.
Thank you. I'll see you at 11:30. Bye.
Thank you, sir.
Okay.